Okay, let's start with the next exercise, with the table. So we are given some information on demand. We are given the relationship between quantity and price, right? And we are also told that the cost of machinery is £1. So we'll need to complete the rest of the table. Let's calculate total revenue first. Total revenue is simply price times quantity. So you have the formula. So what we have to do is simply multiply first two columns by each other. When quantity is 0, regardless of the price, total revenue will be 0. It's 0 times 2.2. When we sell one item, price is £2. It's 1 times 2, so it's £2. This is our total revenue. When we sell 2 units and price is 180 per each, 2 times 180 will be equal to 360. We sell 3 units, 160 each, it's going to be 4.8, 480. Sell 4 units, 140 each, it's 560. 5 items at 120 each, it's £6, 6.0. 6 items at £1 is 6 again. 7 items at 80p is 560. 8 items at 60p is 480. £9 at 40p is 360. 10 items at 20p is £2, 20, and 11 items at 0 is 0. So strictly speaking, this set of numbers, total revenue curve, shows us that our revenue is a curve like that. It goes up initially, increases from 0 to £6. So £6 is our maximum. This is the maximum, the best which we can do. We can earn, we can generate £6, for example, per hour. Quantity and some numbers in monetary values. And then if we keep increasing output beyond this optimal point, total revenue will start to decline from 6 to 5 to 4 to 3 and goes back to 0. So this is how our total revenue looks like, representing change in elasticity of demand. Okay, next, we'll need to calculate average revenue. Average revenue is simply the price. On average, you earn the amount of money which is equal to the price of the unit which you sell. So we simply rewrite the column with the price data. So it's 2.2, 2.0, 1.8, 1.6, 1.4, etc. So simply rewrite what we are given for prices. Price is the same as average revenue. On average, you earn this amount per each unit which you sell, because this is what consumers are paying you. Okay, marginal revenue. To calculate marginal revenue, we need to analyze how our total revenue changes. Let me just use another color. When we increase production, when we sell more units. So marginal revenue shows how total revenue changes. Our denominator change in quantity, in this case, will be equal to unity in all cases. When output increases by 1 unit, total revenue will increase by some amount. So our quantity, in this case, will be equal to 1. So we can simply eliminate this step. It's not like in the previous case where, in the previous seminar, when we've had workers producing different levels of output, we had to pay attention to this. In this case, it's easy. Quantity increases by 1. So we are only looking at the numerator. So we are looking at how total revenue will change between different levels of output. We cannot calculate marginal revenue for the very first line, simply because there is nothing to compare with. Marginal revenue shows how total revenue changes. Here, it doesn't change yet because we haven't started production yet. So there are no data. Next, when we produce the first item, total revenue increases, jumps from 0 to 2. So 2 is our additional revenue generated from selling this first unit. When we sell second unit, total revenue goes up from 2 to 360. In other words, plus £1.60. So this is the difference between 2 and 360. This is our marginal revenue. This is how much extra we earn from selling the second unit compared to what we used to have before. Next, when we sell 3 units, our total revenue goes up from 360 to 480, which is £1.20 extra. This is our additional marginal revenue. Next item, item number 4, will generate us 80p of additional revenue. And so on. Next item, difference between 560 and £6, which is 40p. Next one, 6 and 6, no changes at all, so marginal revenue is 0. Next one, pay attention, marginal revenue can become negative. We used to generate £6 in revenue. Now, when we sell 7th unit, our revenue drops to 560. In other words, marginal revenue, additional revenue is 0.4 with a negative sign. Total revenue dropped by 40p when we've sold this 7th unit. Next, we keep increasing output and our revenue keeps going down. So it was 0.4, now it's 0.8 with a negative sign. We've reduced our revenue. Then it's minus 1.2, this difference. Next, minus 1.6, and eventually we lose all £2. So marginal revenue simply shows us the difference in total revenue numbers. It shows us how much total revenue changes when we jump to the next production level. Okay? Okay, next, costs. Now let's have a look at costs. I will change the color again. I'll use black here. Fixed cost is the cost of machinery. It's the cost of our capital, and we are told that it's £1. And because it's fixed, it means that it doesn't change. So we can simply write 1, maybe 1.0 for consistency, in all our cells. It's £1, regardless of level of output. All the time, it's 1. And what is important is that it's 1 even when output is 0. That's the idea of fixed cost. Output is 0, but we still have to pay this. We don't incur any variable expenditures, so variable cost will be 0. We don't pay to our workers, we don't pay for materials, but we still have to pay for example, hiring this machine. Yeah. Okay? And next thing which we need to calculate is the total cost. Total cost is simply a sum of fixed and variable costs. So we simply add up fixed and variable cost, and this will give us the total number. So strictly speaking, we take variable costs, whatever amount we are given, plus we add £1 on top, because this is what cost of machinery will be. So we used to have 0 plus 1, it's 1. Variable cost 50p plus 1, 150. 70p materials, £1 extra, 170, and so on. Simply add up all these numbers together, simply increase your variable cost by £1, and you will get your total cost data. So it will be 220, 30, 410, 550, 72, 92, 11.5, 14.1, and 17. As you can see here, total cost always go up. Unlike total revenue, we start with £1 and then it goes up. Total cost always increase. Unlike total revenue, which we've had already. The more you produce, it starts at £1 minimum, and then it goes up, all the way up. So if you look at these numbers, they're always increasing. There is no maximum here. The more you produce, the more you have to spend. Okay, let's move on. So next thing which we'll need to calculate, we calculate marginal cost, and I'll use blue color here as well. Marginal cost shows us how total costs change as we change production level. It shows how total cost, how much additional cost each additional unit will generate. And here in our denominator, total cost, total quantity is also equal to unity. So again, it's very simple. Denominator is always equal to 1. So we'll only look at the change in total cost. So we'll simply have a look at how these values change. So initially we cannot calculate. We always can calculate the first data for marginal revenue and marginal cost, because there is nothing to compare with. There is no starting base. And next, for the first unit of output, our total cost increased from £1 to 150. We have to pay an additional 50p to produce this unit of output. Our total cost increased from 1 to 150. Marginal cost is 0.5. Next item, our total cost go up from 1.5 to 1.7. Additional cost is 20p. Next, 170 becomes 220. The difference is 0.5, and so on. Have a look at this difference and calculate these differences. So it's going to be 0.8, 1.1, 1.4, 1.7, £2, 230, 260, and 290. And if you sketch a diagram, it will look like this, marginal cost. So we achieve a minimum which we can enjoy is 0.2, 20p. This is our minimum of marginal cost for very low level of output, literally for 2 units. If you produce more than 2 units, your marginal cost will go up. So if you look at this blue column, right, we can see that initially first item cost us 50p, and then marginal cost drops to 20p, and then that's it, and then it goes up. So it's an idea of marginal cost which has this particular shape. Initially drops slightly for the very low level of output, but for majority of your production level, for your range of possible output which you're going to produce, marginal costs are always increasing. So this is our minimum, and then it goes up all the way for all other possible units. And for majority of companies, this minimum of marginal cost will be very, very low. It will be achieved at a very low level of output. So most companies will always operate along upward sloping part of the marginal cost. Diminishing returns will kick in really, really quickly. Okay, any questions? No? Okay, let's calculate profit now. Profit, I'll use green here. Profit is simply the difference between total revenue and total cost. So we are going to look at these columns, total revenue and total costs, and we'll simply compare them. This will generate us profit. Revenue minus costs. So let's have a look. Initially, revenue 0, cost is £1. Profit is -1. We are making £1 of losses because we haven't started production yet, but we've already paid our fixed expenditure. 1 unit of output made, generated £2 revenue, spent £1.5, which means that our profit will be 0.5. For 2 units, our total revenue is 3.60, our total cost is 1.70, which means that our profit is £1.90. For 3 units of output, total revenue is 4.8, total cost is 2.2, the difference is 2.6. And so on. Just keep working, comparing these numbers. 5.6 minus 3 is 2.6. £6 revenue minus 4.1 pounds cost, 190 profit. £6 revenue, 5.5 cost, 50p. 5.6 profit, 7.2 revenue minus 1.6. So we've started making losses because when revenue is 5 and cost is 7, it obviously means that we are making losses. We are not covering all our costs by generating this this small amount of revenue. Next, 4.8 pounds revenue, 9.2 pounds cost generates us a loss of £4.40p, and so on. 360 revenue, 11.5 costs minus 7.9 negative profit loss. £2 revenue, 14.1 pounds costs minus 12.1 loss. 0 revenue, 17 pounds cost minus 17. So as you can see here, our profit actually starts at negative value. Let me draw it like this. Initially, we start at negative amount, -1. When we just start our business, we don't make any profit. We normally suffer from losses. You don't become profitable immediately. -1. Then we start earning some little profit, 0.5, 1.9, 2.6. 2.6 is our maximum. This is where we've achieved our best maximum profit. 2.6. This is the best we can do in this particular situation. And then profit starts to decline and eventually become negative again. So this is an illustration of the profit curve. Started negative, earned some positive profit, then declines and becomes negative. So strictly speaking, this is our profitable range of output. We should be producing somewhere between these 2 points. These are our break-even points. Let's call them point X and point Y. These are our break-even points, points where our profit is equal to 0. We're just covering our cost of production with our revenue. And if we produce somewhere between these points, we are making positive profit. And the question is where, how much exactly do we need to produce in order to maximize our profit? And to do this, strictly speaking, we need to have a look at the level of output which generates marginal revenue equals to marginal cost. So to maximize profit, to maximize our profit, when you have a very large, very long spreadsheet, when it's difficult, when you cannot plot it properly, you can simply follow this rule. To maximize profit, find the point where marginal revenue equals to marginal cost. So look at your data. So marginal revenue, blue column, and marginal cost, blue column. Let's find the level of output which allows us, which ensures that these numbers are equal. So for example, 1 unit of output, marginal revenue 2, marginal cost 0.5, not equal. 1.6, 0.2, not equal. 1.2, 0.5, they're not equal, not optimal. 0.8, 0.8, they're equal. So this is level of output where marginal revenue equals to marginal cost. 4 units. We achieve our best production at a point where quantity is equal to 4. If you keep comparing the blue columns, you will see that there will be no other points where they're equal to each other. 0.4 and 1.1, 0, 1.4, minus some numbers, some positive numbers, they are not equal. There will be only one unique level of output where marginal revenue crosses marginal cost line. And this will be the situation where our profit is maximized. So we need to be located at 4 points and the 4 units of output. And the last column which we need to complete is average cost. What color should I use? I think I'll use black again. Average cost is simply total cost divided by quantity. So we look at this column now, total cost column, and divide by quantity. So total cost is 1 divided by 0 cannot be calculated. Total cost is 1.5 divided by 1 is 1.5. Total cost is 1.7 divided by 2 items. It's 0.85 per each. Next, sorry, it's this one. 2.2 total cost divided by 3 units. It's about 0.73 each. Next, 3 pounds spent to make 4 items. It's 0.75 per each. Next, total cost is 4.1, 5 items made, which is 0.82. Next, total, am I looking at the right? Yes, so I'm looking at this column. 5.5 total cost spread across 6 units, which is 0.92. Next, 7.2 pounds spent to produce 7 units. This is going to be 1.03 and so on. So if we'll write down all these figures, they will look like that. 141, 155. Right, so this will be your average cost. Can you see well from the screen? Yeah, is everything okay? Yeah, okay, good. Everyone ready? Now let's have a look at our questions. First question, find cost minimizing level of output and find profit maximizing level of output. We've actually found profit maximizing level of output already. So this was question B. To maximize profit, output should be equal to 4. And question A asks you about minimum cost, minimum average cost of production. To answer this question, we'll need to look at our last column, average cost. We are trying to find cost minimizing level of output. In other words, the most efficient level of output which allows us to produce with lowest possible cost. It means cost per unit, because obviously your total cost will be minimized when you don't produce anything at all. But this is not what we are trying to achieve. We try to operate in the market, we try to produce some goods and sell them to customers, and we want to be the most cost effective. Maybe we are just entering this particular market and we want to compete on cost in order to grab the highest possible market share, to attract as many possible customers as possible, to create loyal customer base, and possibly then start making profit on them, maybe selling them additional items or increasing prices, etc. After we've secured this loyalty, we've created this brand identity already. But initially, we might be interested in just producing at the lowest possible cost. So we'll need to look at the minimum of average cost. As we know, average cost curve has a U shape. Let me just change the color again. It has a U shape, so it has a point of minimum. And this is exactly what we are trying to find, point of minimum. Let's have a look at our data, some quantity. 1.5, 1.8, 0.73, so it goes down up to this point, and beyond this point, it starts to increase, 73, 75, 82, 92, and so on. So this is our minimum. This is the minimum of average cost. Minimum of average cost is 73p, which is achieved at the level of output equal to 3 units. When we make 3 units, our average cost is minimized according to our data. So to minimize average cost, quantity should be equal to 3 units. Then average cost will be 73p. And this is the minimum amount which we can generate with our technology, with our cost structure. And please pay attention, to minimize costs, you'll need to produce 3 units. To maximize profit, you need to produce 4 units. These are not the same figures. These are different objectives. In economics, we assume that each firm tries to maximize profit. This is one of the basic assumptions in economics. At least we start with this assumption. We develop our theory assuming that firm wants to earn the highest possible profit. In real life, this is not always the case, and sometimes firms can prefer to pursue some other objectives. For example, cost minimization or sales revenue maximization, and so on. And in this case, they will simply look at their data and select what is most appropriate for them. They will select the best strategy for them. So if they want highest profit, they need to produce 4 items, and profit will be equal to 2.4. If they want to minimize cost, it will be a different amount. Of course, we only have only 10 possible units of output, only 10 possible production levels. In real life, and sometimes they can coincide because we simply have a small amount of data. In real life, when you work for a large company, they will be totally different from each other. The relationships will not be linear at all, and the curves will not be as nicely looking. Nevertheless, the principles remain the same. Look at the data, calculate your data, and strictly speaking, as accountants, you will have to do it very, very many times. You will be working with costs all the time, and you will just need to analyze these costs, and this is how you do it. Your solution, if I switch to the answers, will look like this. So that's the solution. So please make sure that you have these numbers. But you can always download a solution from Moodle. It's available on Moodle to check your answers that everything is correct.